So the first thing you want to do with this problem is write down the numbers you're given at the beginning. So you want to start with t equals 6 because you're starting with after 6 years. You start with 30 grams, that's your P naught, and the population after 6 years is going to be 21 grams. That's all the problem is telling you. So the first thing you want to do is find K, your constant, and the way you do that is you do sub everything in for the Poked equation, e to the 6, because that's your t. K. That may look like a little b, so let me fix that. Yeah, there. That's a little better. But anyway, you're going to get 0.7 equals e to the 6k. Do the ln of both sides. ln of 0.7 equals 6k. And eventually your k is going to come out to be negative point, that's a decimal point, sorry, 0.594. And it's negative because it's decaying. So now we have to back out a few steps and get the derivative of Poked. And since t is what we're deriving for, you want to get the derivative of the exponent, which is kt, and the derivative of that is just k. So you throw that up front, multiply that by your normal equation, which is that p naught times e to the kt, all that right in there. And your k's out here. And then once you've done that, you get to plug in all your numbers again. So you still have the same p naught, that's just 30. You have k from up here, which is what we found earlier. And then you have t, which is now 7, because you're trying to find the derivative after 7. So if you do plug in all those numbers, what you'll end up with is p prime of 7 is going to be negative 1.25 grams per year. And then the units come from grams, which is just your amount, and then when you have a derivative, you do amount per time. And this example, the only time we've been using is years, so we'll use years.